This is the Math 2460 Zoom meeting. Holding it in place of the one on Friday, for Friday, November 20th, but I'm holding it Thursday night. So we're going to finish out working some example problems. We left off in 10.3 on page 715 with horizontal on toll and vertical tangency. All right, and so just to try to explain it again, the full problem is to have a slope in parametric mode. dy dx is dy dt divided by dx dt. For horizontally tangent, you're going to use this and set dt equals 0, because horizontally tangent, your slope equals 0. For vertically tangent, you're going to use this, use, and you're going to set dx dt equals 0, because your slope is undefined. All right, let's try a problem, page 715, like 33. 9 minus t, negative t squared. Find all points of horizontal and vertically tangent. Find all points of horizontal and vertical tangency. And we won't mess with using a graph to check the results. So I guess it doesn't matter which one you do first. I guess we'll do horizontally tangent. dy dt, we're going to set dt equals 0, and dy dt for this is negative 2t equals 0. Divide by negative 2, and your t would be 0. So we're going to find the point, the xy point. So we know the parameter value for horizontally tangent. We just need to find the xy point. So for t equals 0, x equals 9 minus 0. See, I'm plugging t equals 0 here. So equals 9. And y is negative 0 squared, which is 0. So the point is 9 and 0, horizontally tangent. All right, vertical tangent. Set dt equals 0. Well, x is 9 minus t, dx dt is just negative 1. It's never 0. There's no solution. So there's no points vertical tangency. All right, if I did have a t value out of this, and I've frozen, then I would plug that t value into x and into y, see if it'll catch up. It wants to freeze. Give it a few more seconds. If it doesn't, maybe I'll stop the share and hope I can reset it. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, let's stop the share and see if I can get it back. got it on my camera, but doggone it, doesn't want to show on the screen. Wi-Fi is not cooperating tonight. Try again. These work. There it goes. All right. And so, yeah, there's no points or vertical tangency here. All right. The next set of problems, we're not going to mess with concavity, are arc length and surface area. And these are pretty surface areas down here. These are pretty much plug and chug kind of problems. If you remember, arc length I think we did that in 7.4. I don't know if we used S or L, but we had an integral from A to B, big square root, f prime of x, quantity squared dx. And it found between A and B, the length along f of x. I hope you know this for the final. In 10.3 parametric, it turns out you're going to get L equals integral from A to B, big square root dx dt plus dy dt dt. This is, again, y is an f of t, and, or actually x is f of t, and they usually use y as a g of t. So it looks like a Pythagorean theorem. You're kind of doing, again, a straight line along, but the horizontal is dx dt, the vertical is dy dt, and you add them up, take a square them, each one of them, add them up, take a square root, and you've got the length along. And it's pretty much plug and chug, pretty straightforward. Let's try 43, page 716, 43. And x is 3t squared, and a y is t cubed subtract t. So we're doing this right here. I'm sorry, I'm in the wrong section. That's the concavity section. It's 49. My apologies. 49, and that is x equals 3t add 5, 7 minus 2t, and between -1 less than t less than or equal to 3. This is pretty straightforward if you copy the problem right. Your arc length would then be the integral from -1 to 3. Big square root. Your dx dt is just 3 squared. And your dy dt is a -2 squared and dt. And this is easy enough. You could work it out by hand because this is just nothing but a constant. But you'd have length equals integral 1 to 3, the square root of 9 plus 4, which is integral 1 to 3 of the square root of 13 dt. I'll just finish it out by hand. This is the square root of 13 times t, and 3 and 1. And you get the square root of 13 times 3 minus the square root of 13 times 1. If you factor out root 13, you wind up with 3 minus 1, twice root 13. I'll punch that. 7.2111. All right, if I punch it back up here, using math, see math 9, I'll clear it off, math 9, and I do a big square root. I'll go ahead and square them, 9 plus 4, I won't even add them up, comma, x, comma, -1, comma, 3. And why am I off by a factor of 2? Because I screwed up. I dropped my negative. It should have been dropped the negative right there. I look like an idiot. -1 there. And so I really have root 13 -1. So it's really, it's really a 4 root 3, and that doubles it. My fault, 14.222. And that's what, that's what I should get. So it is good to check these things. But the important thing is to know this formula for arc length in parametric mode. All right, surface area. Okay, just really quick, parametric mode. Between an A and a B, the area of the surface. This is L, which is arc length. That's your big square root of dx dt plus dy dt squared. I don't know if you remember how surface, and then you mirror down here. I don't know if you remember how surface area worked, but surface area is circumference times L. That's L. So the length around these circles times the L between them. Circumference is 2 pi radius times L. This is radius. And radius equals f of x. All right, and f of x equals y. And remember, you're given y is f of t, and x is f of t, and y equals g of t. Important thing to remember is just you get y, and we're going around the x-axis. So really, you're getting 2 pi times the y times L, radius is y, big square root dx dt, dy dt, dt. So surface area then equals 2 pi integral from A to B times the y, that'd be the g of t, big square root dx dt, a little more complicated formula, plus dy dt. You got the arc length piece in here, but it's multiplied by this radius term, which is the direct y equation. This is around the x-axis. And if I went around the y-axis, the radius equals x. So it becomes surface area, 2 pi integral, I guess we see in a d of the x, and then again square root of dx dt, dy dt, and dt. Once again around y-axis. And that's what they're trying to show you on this gibberish right here. Now, I never remember if it's g of t or f of t on these things. So what I do remember is you're going around the x-axis. And see how they're telling you that, well, g of t is greater than or equal to 0. But up here, g of t is y. Okay, and then that's what I plug in with the direct y equation in terms of t. And then down here, that's the direct x equation in terms of t. Again, it's really just plug and chug, but it is a little more complicated than arc length. Let's try 63. 63, x equals 2t. Anybody else come in? Y equals 3t between 0, less than t, less than or equal to 3. Let's do x-axis. So that's surface area equal 2 pi integral from a to b of, again, y, that's direct y, square root dt squared plus dy dt dt. So you get 2 pi integral from 0 to 3 of 3t. Big square root dx dt is 2 squared, dy dt is 3 squared dt. Again, this is just a front coefficient, 9 plus square root of 13, just like the last problem. So that's 2 pi square root of 13. We also have a 3 from here. Is the integral 0 to 3 of t dt. And I will let y'all punch that. They're really 6 pi root 13. I'll let y'all punch that. And in B, you'd have, this is a y-axis. You would have 2 pi integral from, now this is going to be, no, actually, same thing. You're doing in terms of the parameters. So it's really 0 to 3. You don't have to worry about x numbers and y numbers. Yeah, but you do need to put in the x. So that's 2t. Again, big square root. All this worked out to be root 13 dt. So that's going to be a 4 pi root 13 integral 0 to 3 t dt. Going around the y-axis. I'll let y'all punch that. It's pretty straightforward. Just a little long. And that finishes up 10.3. So we jump to 10.4, and what we have in 10.4 is polar coordinates. Polar coordinates, this is our intro to coordinate systems. There'll be a lot more coordinate systems further on in Calc 3. To coordinate systems. All right, let me just make an example. Let's say, should I use easy numbers? Let's say I want to go, well, we'll just use x's and y's. This is basic trig. I locate a point with just general x and y. This is called rectangular. And you can denote it as by the sides of the triangles. You're over x and you're up y. But you also know there's a radius out and an angle that point makes. And the coordinates r then theta are called the polar coordinates. Okay, so there's one set of rectangular coordinates for any point, but infinite set of polar coordinates for any point. We will point this out here, why that is. All right, let's use some numbers, try to make this more concrete. Let's just use 2 and 2. So this is rectangular, which means this is X and this is Y. And I'm supposed to find my R and theta. R here, theta here. Well, you know, on the trial, this should be 2, this should be 2. It's pretty straightforward. R squared would equal 2 squared plus 2 squared, which means R squared equals 8. 4 plus 4 is 8, and R is the square root of 8. And you see the tangent theta is y over x, which is 2 over 2, which equals 1. And theta then is arctangent of 1. You tell that is pi over 4. So my polar coordinate is root 8 pi over 4. But you see, you get to the same point if I went root 8 and pi over 4, add 2 pi, which is 8 pi over 4. I don't know if I can squeeze it in, but that means you get root 8, 9 pi over 4. And you can play this, you can keep circling, adding 2 pi to infinity and subtracting 2 pi, getting an infinite number of angles that all refer to that same point. So that's why there's infinite polar coordinates, but only one set of rectangles. It's only over so far, it's only up so far, and that's it. Okay, formula for this thing. This is called rectangular to polar. See what we've done? You basically went R squared equals X squared plus Y squared. All right, which means R squared is X squared plus Y squared. And so R would be the square root of X squared plus Y squared. All right, and tan theta, already written really right here, is Y over X, which means theta is the arctangent of the ratio Y to X. So this is how you get to R and theta from X and Y. But you can reverse it. That's called polar to rectangular. So if I am given R and theta, find X and Y. Well, can you see that cosine theta is X over R, adjacent over hypotenuse? This is why it's just nothing but basic trig. So your X is R cosine theta, sine theta, Y over R, opposite over hypotenuse. Y would then be R sine theta. Multiply both sides by R, multiply both sides by R, multiply both sides by R. And those are simple equations for X and Y if you know R and theta. All right, well, this section is going to be about manipulating these equations first, and then it gets into some calculus. And the calculus is pretty darn complicated, but it's nothing but, they show you the formulas in this section. It's nothing but plug and chug into them. So let's see if we can just work down through some homework. All right, they just start off with these conversions. Page 726, number 5, 8 in pi over 2. These are polar coordinates. They have to tell you that because you could actually work this in rectangular coordinates. Right, so number 5, this is on page 726, polar coordinates. let's see, 8 pi over 2. Plot the point. See, if these are polar, that's an r, that's a theta, which means you are 3, 4, 5, 6, 7, 8 directly up the y-axis at pi over 2. Angle is pi over 2. So there's a point. You just draw a dot at it. There's plot the point. You could probably do the rectangular in your head. The rectangular would be x is 0 and y is up 8. But if you want to use the equations, x equals r cosine theta, which is r8 cosine pi over 2, which is 8 times 0, which is 0. Y equals 8 sine theta, which is 8 sine pi over 2, which is 8 times 1, which is 8. And there's your coordinates, 0 and 8. X is 0, y is 8. So yeah, sometimes they give you simple pictures you can do in your head, but you can always use the equations. All right, then they reverse it. Look at 15. Plot the, let's see, the rectangular coordinates of a point are given. Plot the point, find two sets of polar. Okay. 1 and 0, and this is rectangular. That makes this an X and this a Y. All right, find, and again, you can probably do this in your head. You're over 1 up 0. That's the plot. Well, your R and your theta, your R would equal 1 and your theta would equal 0. You can see that. If you want to use equations, R is the square root of x squared plus y squared. If you want to just blindly plug and chuck and do equations, you have the square root of 1 squared plus 0 squared, and that would be 1. And your theta is the arctangent, y over x, which is the arctangent, 0 over 1, which is the arctangent of 0, which is 0. So equations work, but if you plot the points, now sometimes they give you nasty numbers and you don't know what you got to use the equations. Okay, so then with algebra with this, they want you to convert. This is, say, problem 25. This is a rectangular equation. Convert the rectangular equation to polar form, sketch its graph. X squared plus y squared equals 9. So this is where you got to know all your equations and know which ones to use when. So R was the square root of x squared plus y squared. You see R squared then is x squared plus y squared. So you can put R squared over here equals 9. And R then equals square root of 9, which is 3. R is positive. You don't really need to mess with plus and minus. So this is called the polar form. And they want a graph. We're going to use the TI in polar mode. Oh, but I'm upside down. How did that happen? this. It's a miracle. Okay. So this is the second mode of this chapter. If you go to mode, and yeah, you want to be in radian mode. And run down, we've used parametric in 10.2. We want to use POL, polar mode in 10.3, 10.4, I mean. Enter, polar mode. Quit. So if you go to y equals, now you see, you get nothing but our equation. The calculator plots R is some function of theta. All right, you get this function of theta, like if I hit twice and this, see, when I hit this X key like you're used to, instead of getting X in polar mode, you get theta. All right, but we don't want that. In this one, we want just 3. So super simple entry. When I go to window, just like before I had a Tmin, Tmax, T-step, that was just a random parameter. I'm getting an angle, a minimum angle, maximum angle, and a step on the angle. And then you get your negative 10, 10, 1, negative 10, 10, 1. And so if I graph, that's supposed to be a circle of radius 3. You can recognize that as a circle centered at the origin with r equal 3, r equal the square root of this. There is its polar form. R equal 3. All right, should we try one more? How about 31? Convert 3x minus y, add 2 equals 0. Now, if you remember, x is equal to r cosine theta, and y is equal to r sine theta. I'm going to sub in 3 r cosine theta minus r sine theta equals 0. All right, I'm going to go 3r cosine. I'm going to solve for r. Sub in, solve for r. Cosine theta minus r sine theta equals a negative 2. Factor out r, 3 cosine theta minus sine theta. So r equals negative 2 over 3 cosine theta minus sine theta. This is dangerous. I've been trapping myself on some of these. Let's give it a try. 10.4, number 31. 10.4, 31. There we are. Negative 2 over 3 cosine minus sine. Sine minus sine. Okay, then they wanted a graph. Sheet here. And so if I want a graph, here's that, and I get a negative 2 divided by, and you're going to put this in parentheses. Parentheses 3 cosine theta close minus sine theta close close. Window graph, and it works out a straight line. You should be able to, it doesn't go through the origin, it goes a little above it. All right, and you can kind of see, if you put the y over, you're basically getting y equal 3x plus 2. And if I graph this in function mode, you see I got a y-intercept of 2. Yeah, it looks like it's crossing at 2, slope of 3. And this is its polar form, and you're going to get the same graph in polar mode that you would in rectangular mode. All right, then you can reverse it. Problem 35. This is polar to rectangular conversion. So 35, we have r equals 4. Well, if you remember, r is the square root of x squared plus y squared. Plug that in. 4, and they usually like these solved, so I square both sides, x squared plus y squared would equal 16. Hope you recognize a circle centered at the center of 0, 0 with r equal 4. So you could draw that. You could draw out a radius, just exactly like the r equals 3 back in the 25. But yeah, you get a circle with a radius equal 4 in polar mode. And that's the rectangular form. This is polar form. This is rectangular. Why don't we try something like 41? 3 secant theta. Convert to rectangular. All right, well, just like up here, r is the square root of x squared plus y squared. Plug that in. Over cosine theta. Secant over to cosine. Now remember, x is r cosine theta, so cosine theta is x divided by r. So you're going to get square root of x squared plus y squared equals 3 over x divided by r. Okay, and so that's 3 times r over x. And that r was the same as this r. You can see they divide out, but I'll write it out as x squared as well. So x squared plus y squared, 3 square root of x squared plus y squared over x. You can divide both sides by this, leaving 1 equals 3 over x. So you can see, multiply both sides by x equals 3. It's a vertical line. You cannot graph this in rectangular mode. It violates vertical line test. But you can graph it in polar. And just to show you, you'd have to enter it as 3 divided by cosine theta. And just to show you do get a vertical line of x equals 3. 1, 2, 3. Show you. Here. Go 3 divided by cosine theta. Graph. And there you are. That's the only way to graph a vertical line on this calculator, because the calculator in function mode only handles functions, y versus x. All right, let's let y'all, we're going to jump all the way over to problem 63. That's where the calculus is. Find dy dx and slopes of tangent lines. So you're going to plug in numbers at these 3 tangent lines. Very little calculus here. Really 63, 65, and 67. Okay. The only calculus is to find dy dx in polar mode. Page 723, and you find this gibberish. Okay, the best way to explain this gibberish, maybe I will copy it down, take time dy dx you get f of theta cosine, f prime of theta sine over negative f of theta sine, f prime of theta cosine. Now, the best way to keep track of this gibberish is to realize r equals f of theta. So r prime derivative is f prime of theta. So I prefer dy dx r cosine theta plus r prime sine theta over negative r sine r prime cosine. We don't really derive this or show you where it comes from. It's the last nasty formula of the semester. I know that breaks your hearts. To use it, it's pretty straightforward plug and chug. So if we go to 60, I guess I'll stop at the clean G because this is going to get long. 63, and then give you r equals twice and 1 minus sine theta. And they want you to find I dx, and there's 3 points. There's at 2 and 0. There is at 3 and 7 pi over 6. And at 4 and 3 pi over 2. I don't know if I get them all in, but these are r's and thetas. You should already know 2 of the answers. The one down here, see how that's horizontal, you dy dx should work out 0. And here it should work out undefined. And not sure how this will work out. It should work out negative. I can tell it's negative. Other than that, I hard to tell the number. All right, so I don't know if you want to number these 1, 2, and 3. Why don't we show number 3 first? dy dx should be 0. Okay, we're going to need an r prime. R prime, looking up at this, you'll have your 2, and you'll have cosine theta, negative 2 cosine theta. If this goes away, you'll have a negative cosine theta with your 2, negative 2 cosine theta. All right, here's the formula. dy dx should be r 2, 1 minus sine theta, cosine theta, plus negative 2 cosine theta, sine theta. Let's see if we need to pause for station identification here. Put in r cosine plus r prime sine. So this is the r cosine. This is the r prime sine. So that's divided by negative r sine, negative 2, 1 minus sine, sine. This is 2, 1 minus sine, right here. Sine plus negative 2 cosine, cosine. R prime is negative 2 cosine times cosine. This is r prime cosine. This is negative r. All right, and now I could simplify this and do the algebra and simplify it down, but since they've given me numbers, and I'm using 0.3 here, I'm just going to plug in 3 pi over 2. So dy dx, 2, 1 minus sine, cosine 3 pi over 2, minus 2 cosine 3 pi over 2, sine over 2, negative 2, 1 minus sine 3 pi over 2, sine 3 pi over 2, plus -2 cosine 3 pi over 2 cosine 3 pi over 2. Not really hard, it's just long. Okay, so a sine 3 pi over, let's see, cosine 3 pi over 2 is 0. Remember at 3 pi over 2, you're down here. Cosine 3 pi over 2 equals 0. And you got 1 here. So your top is 0. Y dx is 0 over whatever this is. I hope that's not 0. Should we check for that? This is going to be 0 down here, that piece, but you're going to have -2, 1 minus sine 3 pi over 2 is -1, and then -1. Yeah, you're going to get 0 over -2 times 2 times -1. That'll be 0 over 4. Sure enough, you get 0, and that's exactly what they show right here. On this point, you're going to get the bottom of that horrible dy dx formula being 0. The top will be something else. The bottom will be 0. And that's where you're going to get an undefined slope. And then this, you're going to, who knows how it's going to work. You're going to plug in theta 0 on things, and it's going to work out how it works out. Maybe I should do problem 1. It's the last one. I don't really have to rewrite the formula. The formula is right here. I'm just going to plug in for problem 1. I'm going to call it point 1, which was 2 and 0. Plug in theta equals 0 into this. Kind of horrible and long, but it's not that hard. If I can keep that in the picture. So dy dx would then be twice 1 minus sine 0 cosine 0. -2 cosine 0 sine 0. -2 1 minus sine 0. So that's a 0. Sine 0 plus -2 cosine 0 cosine 0. All right, this is 0. Sine 0 is 0. I wind up with 2 cosine 0 is 1. So I really wind up with a 2 there. Sine 0 is 0, which kills this whole thing. Bottom. Sine 0 is 0. Okay, sine 0 being 0 kills this whole thing. And I wind up with cosine 0. That's a 1. That's a 1. Something. I get a -2. I works out a -1, which I guess makes sense. Look at the picture. Apparently that slope is -1. All right, that's a pretty good intro to all of the kind of problems through 10-4. Feel free to email me with any questions. Test 4 is tomorrow. And we will have it due Monday. Next Zoom meeting, Tuesday, 11/24, 9 a.m. We'll go over final exam review. We have test 4, Friday, 11/20, due Sunday. 2 covers 11.2, 10.2, 3, and 4. We'll end the meeting and look forward to seeing you next Tuesday. Thank you.